Hello and welcome to the Chemistry Industry and Society Show. My name is Luke Chang and I will be your host. Today, we will examine the use of radioisotopes in our modern-day society and its industries. We will also discuss some of the disposal problems that are associated with these radioisotopes and solutions to these disposal problems.
Reference of radioisotopes and nuclear reactions discussed in this presentation can be found in chapters 2.1 and 4.4 in the McGraw-Hill Grade 11 Chemistry textbook.
A radioisotope is an isotope of an element with an unstable nucleus. When the nucleus decays, it releases radiation in the form of alpha, beta, and gamma particles through alpha, beta, and gamma decay. Energy is also released as a part of the decay process. In the power generation industry, radioisotopes are used to generate electricity. In nuclear generating plants, nuclear fission reactors initiate induced nuclear fission in radioisotopes such as uranium-235. The decay of these radioisotopes releases great amounts of energy in the form of heat, which is used to heat water. Steam from the heated water turns a turbine, generating electricity. In the medical industry, radioisotopes are used for many purposes, from diagnosing diseases with CT scans to treating cancer with radiation therapy. Numerous lives have been saved with the aid of radioisotopes. Radioisotopes are also used in the military industry. They are used to produce weapons, nuclear warheads, and are used as fuel for propulsion systems in military vehicles such as submarines. However, this powerful resource does not come without its problems. The disposal of radioisotopic waste is a major issue in our society today. Radioisotopes emit alpha, beta, and gamma radiation, as mentioned earlier. These kinds of radiation have been known to cause genetic mutation, radiation sickness, and cancer. The problem with radioactive waste is half-life. Half-life can be defined as the length of time it takes for a radioisotope to lose half of its radioactivity. Uranium-235, for example, has a half-life of about 740 million years. This means it takes 740 million years for it to lose half of its radioactivity. Improper disposal of radioactive waste can contaminate the environment around us, posing a significant threat to the whole biosphere. Let's examine the contamination of Lake Karachay in Russia. This is Lake Karachay, a small lake in the southern Ural Mountains in western Russia. In 1945, the Soviet Union constructed a secret city near the Teka River, where nuclear arms would be manufactured. By 1948, nuclear reactors were in operation and were producing plutonium-239 from uranium-238 fuel. Waste products produced, including strontium-90 and cesium-137, were disposed of in the nearby Teka River. Strontium-90 undergoes beta decay, while cesium-137 undergoes beta and gamma decay. Both strontium-90 and cesium-137 have half-lives of about 30 years. By 1951, villages along the river had become extremely contaminated through drinking water, livestock, and crops. Realizing this, the Soviets redirected the waste to Lake Karachay, reasoning that the waste would stay in the lake as it had no surface outlets. As a result, the entire lake became extremely contaminated with radioactivity. In 1967, a drought struck the area and the lake was drained to about half of its depth. The wind carried radioactive dust particles into the air, contaminating about 900 square miles of land. about 500,000 people in nearby towns were in contact with the radioactive dust. Cancer rates and radiation sickness soared in the region. If you were to stand beside this lake today, you would receive a lethal dose of radiation within only 5 minutes. This lake is now considered the most polluted location on Earth.
Uranium is found mostly as uranium-238 in nature. Uranium ore is about 99.3% uranium-238. Only 0.7% of uranium ore is the uranium-235 isotope used in nuclear fission reactors. A gas centrifuge is used to enrich the content of uranium-235. The centrifuge rotates at high velocities, and the heavier uranium-238 atoms collect near the outside of the centrifuge, while uranium-235 atoms collect near the center. A major waste product produced is depleted uranium, consisting of uranium-238 isotope. The long-standing solution has been to use depleted uranium in weapons and munitions, taking advantage of its high density. However, military personnel have complained of many health hazards associated with exposure to depleted uranium, such as cancer and the Gulf War syndrome.
The consequences of improper radioactive disposal can be devastating. This is why a safe, methodical process must be utilized in the disposal of radioactive waste. Now, let's take a look at modern-day disposal of spent nuclear fuel wastes produced by a nuclear power plant. This is a nuclear fission reactor. Inside the reactor, a neutron is accelerated into the nucleus of a uranium-235 fuel atom. This equation signifies the nuclear fission reaction that occurs. As you can see, this fission reaction produces 3 neutrons. These 3 neutrons will then respectively initiate fission in 3 other uranium-235 atoms, starting a chain fission reaction. This equation is only one of many possible reactions that result from nuclear fission of uranium-235. Eventually, after numerous fissions, the fuel becomes depleted of uranium-235. Every year, about 27 tons of spent fuel is removed from a single nuclear reactor, containing various radioisotopes with half-lives varying from a matter of seconds to thousands of years. The spent fuel is highly radioactive and must be processed accordingly to avoid serious environmental and health hazards. For spent nuclear fuel, the delay and decay disposal method is employed. This means that the waste fuel is allowed to naturally decay into stable isotopes over time while minimizing impact on the environment and society. This is a storage pond for spent fuel rods of nuclear reactors. Here, the water acts as radiation shielding and also helps to absorb heat energy released from radioactive decay in spent fuel rods. If heat is not absorbed in time, the fuel rods may overheat and may detonate. The fuel rods are stored for several years in these storage ponds. Afterwards, they may be reprocessed by extracting residual uranium-235 for use in new fuel. The alternative is to vitrify these waste fuel rods or immobilize them by encasing it in glass. The vitrified waste is then stored for at least 40 to 50 years in isolation from the environment in special storage facilities. Finally, it is buried deep underground. After about 1,000 years, the radioactivity in the waste will finally have decreased to moderately safe levels. Managing radioactive waste is very important in keeping our society and our environment clean and safe. Canada has always been proactive with sustainable management of its radioactive wastes. In the 1920s, Port Hope was the site of a radium processing plant that extracted radium from pitchblende ore. As a result of this operation, radioactive wastes were strewn across Port Hope into local landfills. Currently, around 2 million cubic meters of radioactive waste is spread across Port Hope, including in contaminated soil. An ongoing initiative by the Canadian Nuclear Safety Commission is the Port Hope Area Initiative. This initiative consists of two projects, the Port Hope Project and the Port Granby Project. Both projects seek to relocate exposed radioactive wastes to long-term waste management facilities. In the fall of 2010, the construction of an air monitoring station was completed, as well as drilling and soil sampling analysis at various contamination sites. The construction of the long-term waste management facility is underway as well. The Port Hope Area Initiative is expected to continue to benefit the area for hundreds of years. Radioisotopes are powerful assets to the human race, but we must learn to manage and properly dispose of waste products or suffer catastrophic consequences. Only then can we pave a brighter way for our future generations. Thank you for watching the Chemistry Industry and Society Show. We hope to see you soon once again. Bye.